Hello everyone. We are going to work through a few more problems. So these are problems from chapter 24 on performance evaluation and performance attribution of managed portfolios. So here is problem number 11. So it gives us information about the performance of a money manager, and it basically gives us the actual return for all the three asset classes that the fund manager invests in, and gives the actual weights that the fund manager used in the portfolio. And then here is the benchmark information. So the benchmark has these are the weights. So that is 60% in equity, 30% in bonds, and 10% in cash. And here are the benchmark index returns. So we have to go ahead and calculate the fund manager's return and then compare it to the benchmark, see whether they overperformed or underperformed, and then see if we can attribute the performance to security selection or asset allocation. So we've seen this in the lecture slides. So what I want to do is to make sure that we understand how this works. So let's walk through a really simple derivation. So let's assume that there are two asset classes, okay, asset class 1, asset class 2. So this can be stocks or bonds, for example, okay. And whatever I'm going to use in the lower case, that's going to be for the portfolio. Uppercase is going to be for the benchmark. So I have two portfolios, two assets in my portfolio. The weights are W1 and W2, and keep in mind they should sum up to 1. So my portfolio return is going to be W1 R1 plus W2 R2. Okay, and keep in mind these are all lower cases because that's for my actual portfolio. What will my benchmark return be? So it's going to use the benchmark weight 1 and the benchmark return 1 plus the benchmark return 2 times the benchmark weight 2. So these are all upper cases, so that's for the benchmark. So the performance that we are trying to explain is the difference between the actual return and the benchmark. So this is the difference we are trying to explain. Okay, and we want to go ahead and decompose this into the asset allocation and security selection. So I have color coded this so it becomes a little bit easier for us to see. So what I want to explain is this difference. So that's W1 R1 plus W2 R2. There's a portfolio return minus the benchmark return. So what I can do is basically add and subtract this quantity. All right. So this is W1 R1 plus W2 R2, and I'm subtracting the same thing. All right. So basically adding and subtracting, they'll cancel out. So this equality still remains. So why do I want to add and subtract this? So the reason I want to add and subtract this is because then I can rearrange this right hand side by the asset class. So I want to get everything for the asset class 1 together. So that is this W1 R1 minus uppercase W1 R1 plus lowercase w1 uppercase R1, that's coming from here, and then the final term is coming from here, minus W1 R1. And then I have the stuff for the asset class 2. So what I want to do is to show you how I can decompose this performance for asset class 1. So I can go ahead and basically rearrange these terms, right? So it's W1 R1 minus W1 R1, right, uppercase, and this is lowercase. Now you can see this uppercase R1 is common to both, so I can take that out. So it will be the uppercase R1 times lowercase w minus uppercase W, which is portfolio weight minus the benchmark weight. So this we know is our asset allocation component. Okay, plus now here I can see what is common is my actual portfolio weight W1. So I'm going to take that out of the as common, and then I'll be left with my actual portfolio return minus the index return, and this is coming from your selection. So you can see now how I can decompose this difference into asset allocation and selection. Okay, so that's the basic logic for why or how we get this asset allocation and selection. All right, so this is basically like a derivation of the performance attribution formula. So I can go ahead and calculate the benchmark return. So that's going to be 60% times 2.5, 30% times 1.2, 10% times 0.5, and I'll be getting an total portfolio, the benchmark return as 1.91%. I can do the same thing for the actuals, but now use the actual weights and the actual returns, and that I can see is 1.65. Basically, that's telling me that this fund manager has underperformed the benchmark by 0.26%. So now I can calculate the security selection component, which is going to take the portfolio weights as a given and is going to times that by the portfolio return minus the benchmark return. So that's basically what I'm doing here. I'm taking the manager's portfolio weight, and then I'm taking the manager's actual portfolio return minus the index return. So I can see for equity you earned 2%, the benchmark was 2.5, so the difference is minus 0.5. So minus 0.5, that is happening on 70% of your portfolio. Because your portfolio is 70, then on 20% of your portfolio you earned 1%, the benchmark earned 1.2, so you basically lost 0.2% there. So you can get these products, add them all up, and you will see security selection contributed to negative 0.39% or a loss of 39 basis points. Asset allocation, I can do it like this. So I'm going to take the difference in portfolio weights and multiply it by my index return, benchmark return. Okay. So I know that for equity, I have 70%, the benchmark is 60%, so the difference in weight is 10%, and I'm going to multiply that by my benchmark return of 2.5%. So that's what I need. Okay, uppercase is all for the benchmark portfolio. So I have overweighted it, but that went ahead and is going to earn 2.5%, so that's contributing 0.25% overall. I underweighted bonds, so that I'm losing minus 0.12%. So overall here I am gaining 0.13%. Okay, and there's zero on the cash because the benchmark weights, there's no difference. Okay, so asset allocation, I'm gaining 0.13. Security selection, I'm losing 0.39. So the total is a negative minus 26, minus 0.26%, or negative 26 basis points, which we know was the actual underperformance. So now I have gone ahead and attributed this underperformance to security selection losing so much, and the manager is partially making up for some of it through asset allocation. Okay, so this is basically how we can do that. So now let's work through another problem. So here's an example of a portfolio manager who's managing this fund, and the benchmark is for in this example is the S&P 500, and they they went ahead and performed very well because the return was 10.2%. The S&P was minus 22.5. Okay, and what the manager did was they changed the market allocation, and they basically invested 50% in stocks, 50% in cash. Whereas for the S&P, it was 97% stocks and only 3% in cash. Okay, and the RF is given to be 2%. So here is the information for the fund and for the index. So we have to calculate the Sharpe ratio. So how can I calculate the Sharpe ratio? First, calculate the excess return for the portfolio. So that is 10.2% minus RF minus 0.02 divided by the sigma. So that is 0.2216. Do the same thing for the index. So the return minus RF divided by sigma, which is minus 0.5568. Now I can calculate what is called the M squared. So keep in mind, what is the M squared measure? You're going to use the fund and some investment in the risk-free asset so that you are able to mirror the sigma for the index. And then you're going to compare the returns on this hypothetical portfolio with this. Okay. So we want to go ahead and invest some amount in the fund, some amount in the T-bills, so that the portfolio has the same sigma as the market. Okay, as the benchmark. So I want to do that. So this will give me a ratio of, or a W of 1.189 in the fund and minus 0.189 in the T-bills. Okay. So once I have those two weights, I can calculate my portfolio return. So the weight in the Miranda fund times the return on the fund, which is 10.2, minus the RF times the risk-free rate, the investment in RF times the risk-free rate, which is 2%. Okay, and then you will see that you get 11.75. What was the return on the benchmark? Minus 22.5. So 11.75 minus 22.5. So your M squared measure is 34.2%. Okay. Now, how do I calculate these weights? So I can go ahead and calculate the weighted average, right? So W1 times this sigma plus W2, which is the same as 1 minus W1, times the sigma for the risk-free rate, which is 0, should equal 0.44. So that is why I have this here, that W1 is basically 0.44 over 0.37. Okay, that's W1. And 1 minus W1 is my W2. Okay. Part C asks us to calculate the trainer measure. So the only difference is I'm going to keep the same numerator, but then I'll divide by my beta, and the beta is given to be 1.1 for the fund, 1 for the market index that we know. So just plug in the numbers, right, and you can calculate the trainer ratio. Part D asks you to calculate the Jensen measure. So Jensen's measure is just the Jensen's alpha. So how do we calculate the alpha? It's the actual return minus the expected return. So we know the actual return for the fund was 10.2%. So that is actual return 10.2% minus expected return is coming from the CAPM. So my risk-free rate was 2%. The fund beta was 1.1 times RM minus RF. RM was minus 22.5%. So plug in all the numbers and you will get an alpha of 35.15%. So this is basically how you can calculate all of these measures for evaluating performance of a managed portfolio. So we know higher Sharpe ratio is good, higher trainers ratio is good, a positive alpha is good, and so on. So this is basically how we can calculate them. And this shows you, this example shows you how to do the performance attribution. So make sure you work through these examples and make sure that you know how these calculations work out and why we are able to decompose the actual performance, benchmark adjusted performance, into asset allocation and security selection.